Hi, welcome to the NXP booth. We're excited to talk about what we're doing in automotive. I'm Brian Carlson, Global Marketing Director for Automotive Processors at NXP.
And you have a new launch.
Huh?
You have a new launch.
Yeah, exactly. That's what happened here. I spent most of my time talking about this chip here. It's the S32 N55, and we call it a super integration, vehicle super integration processor. And effectively what we're doing, what's really innovative about this is that we can take what today is dozens of boxes or electronic control units, ECUs, super integrate those into a single chip. I like to say we used to put chips into boxes. Now we're taking the boxes and putting them in the chip, basically all those functions.
So the SoC gets more stuff on it.
It's more stuff. This is 5 nanometers, by the way. And the way we did that is through 5 nanometer technology. We're the first to have a functionally safe 5 nanometer device like this. And being able to integrate so many boxes. In fact, if you look, this is actually inside the chip, the software. So look at it, we can do chassis, propulsion, safety, energy management, power management, battery management, HVAC, body, OTA, and SDV management. So all these functions can run simultaneously.
They used to be external.
They're all external boxes, and now we're converging those into a single chip. That, by the way, the boxes before, they were about isolation because they're physically separate boxes with just wires. That's the problem, because when you have a lot of boxes all over the car, some cars have 40, 50, some have 150 on high end. The cables, you're talking kilometers of copper, right? And so
are you compatible with 48 volt architecture?
Well, we do have 48, we address that through our system power management and 48 volt. What we're focused on, this one showing, is the new architectures. Let me finish up on this real quick, is that we have all of these cores within the chip. And so what we do is you have cores, you have memory, you have peripherals, you have I/O pins, interfaces. And what we could do is actually you could pick and choose what you want for that function. And everyone has their own resources. They can't interfere. They're physically isolated. We call it software-defined, hardware-enforced. That's what's required to put so many functions into a single chip like that to make sure they don't interfere. And if there was a fault in one, it doesn't bring down the whole car, right? That's always the concern, but they're physically isolated. So that's the inside of the chip. That's the chip in the broader sense. This is in the central vehicle computer or vehicle controller. It's think of that as the brain of the vehicle. Now you also have infotainment and ADAS functions that sit on top, typically modules. But this is the whole vehicle. What makes a vehicle, right? All the safety types of things. And so the second level is the actual architecture of a vehicle. So where these software-defined vehicles are going are called zonal architecture. So instead of 50 to 150 boxes scattered all over with all these wires like spaghetti going all over the place, it's now going to be these architectures that are very clean. They use Ethernet, so you have two wires basically that allows you to transmit data across the vehicle. You have a hierarchy, kind of the low-level stuff with sensors and actuators. We have that with our S32K1. You have zones, which does multi-domain within each area of the car. So this may control all the lighting and things within this section of the car. And then you have the master brain. That's where we focus here. That's your brain of the whole vehicle. And so that's basically what we're showing here. But the real value, let me show you. This is part of what we just introduced this 2 weeks ago. The S32 Core Ride platform. It brings all the software, the hardware, and then we pre-integrate software with world-leading software partners like OS partners, hypervisors, but also tier ones. So we actually pre-integrate software that allows tier ones and OEMs to build applications very quickly. So let me show you an application, a value proposition of the software-defined vehicle and what we can do here. So this is one of them we talk about is personalization. Now there's some aspect of personalization in the vehicle today. This is going to a whole nother level because with an SDV and where every function is updatable and configurable, we'll be able to show that in this architecture. So this says in the infotainment, there's a personalization package, purchase it. I'm going to select that. It loads it, it downloads. You can see all the blue going on. The OTA was blue, the cloud was blue, it's all working. So it's in place. So what we did here is we downloaded and updated the whole vehicle with a personalization package that we can customize. But for now we have 2 drivers, and actually if you look at the fob, NXP driver 1, we have NXP driver 2. So if I put this down on the pad, if I'm entering the car, it knows I like to be a sport driver. And you notice the range. I have 140 kilometers left on my electric vehicle battery. It configures my lighting to be yellow. The wheels are moving really fast. That's high propulsion, torque. and the lights are bright, more aggressive. Now, if I want to be driver 2 and I enter the car, the whole car will become what I want to be. And look what's different. I'm an eco driver. Look at my range. It went from 140 to 170, right? So we can give you a different driving experience, different types of handling and feel of the vehicle. You can totally personalize throughout the vehicle. In fact, if you look at these boxes here, these are the ones that we updated. It's showing you the ones that we updated. So we're deeply going into the vehicle and be able to personalize it. The other thing I'll show here is safe fault recovery. As I mentioned, when you have all these functions in a single chip, what happens if there's a fault in one of them? So I'm going to inject a fault in the HVAC system. And the thing to watch is when there's a fault that the HVAC system stops, the rest of the vehicle keeps going. The wheels keep spinning, the lights, everything still works. So you see, climate control had an error. This is red, showing you that red path, and the fan actually, the fan stopped running, right? So it is fault injected. I can reset that, or in this case, they said there's a new update to fix this problem that was in your HVAC system. Let me go ahead and clear that and update that. And what that'll do is update that and it'll run. Now the key message here is that was able to do that totally independently. I'm driving down the road, it can be fixed without having to shut down the vehicle, go to the side of the road, or go to a shop. We're able to update the vehicle, and you can see that indicates that that's a new update. The HVAC was updated, everything's running, and key is the fan's running, right? So it's back up and running. So we didn't bring down the rest of the car. So that's a key part of SDV personalization and showing how this chip has isolation and that you can have multiple boxes within the chip effectively without impacting each other. Freedom from interference.
So are you on the leading edge of the software-defined vehicle?
Well, definitely, we're across the whole vehicle. This is the latest innovation. We're the first to market to be able to do super integration. That's in 5 nanometers, the first automotive-grade 5 nanometer safe device that can do that. So,
is there any chance that all these other things can be integrated there too? So you just have one thing doing everything?
That's a great question, and that's what's going to happen over time. So what happens is the functionality that's in here will start to migrate into here, and part of our message for the S32 Core Ride is that it has portability, so I can move workloads from one processor to the center. And what will happen is these zones over time, in some cases we see people those will become more aggregators, I/O aggregators. So you're controlling everything from here, and these are basically taking the Ethernet and then taking out the control signals to control it, but the brains will be here. So rather than brains in your leg and brains in your hands, you put the brain in the brain and it controls this, right? And this is just the I/Os.
Does it make sense to have a backup brain
yes,
in case
that does
all
happen.
the cars do that or not? Or
yeah,
some
so this has built-in redundancy, and one thing in the chip it has is called fail operational. So traditionally a lot of cars would have fail safe. So if something happens, it would fail in some safe mode, some static state. This has fail operational, so it can not only know when there's a fault, it can detect the fault, determine where the fault is, and actually try to recover from the fault. And that could mean, it could be a simple, it could recover by going to another processor and dynamically changing, or it could drive to the side of the road. So there are maneuvers. This is really important, especially for autonomous cars where there's no driver.
You don't want to get a blue screen in the middle of the highway.
Yeah, exactly. So there are these recovery mechanisms to do that. So quite a lot going on here, but you hit some good questions about moving into the central compute from the zone. And the thing about this is just our first device, and we will have a whole family of S32 N devices.
We can only guess what could be coming.
Yes, so we already gave a hint of what's coming, right? There's more machine learning, some more PCI Express, some more Ethernet networking and capabilities, but really, and lots of application processing. So this thing only becomes more powerful.
Is that the main brain of the computer?
This is the main brain of the vehicle.
Of the vehicle, but not it doesn't necessarily do the self-driving?
Okay, this is the good question. This is what I'm going to talk about, is what we see in these architectures, and we work globally with the OEMs, is they typically have a board that has all the vehicle functions, all this vehicle functionality in the same box, this whether they call it an HPC or a central compute, it'll have another, either 2 modules or a board on top, which are the IVI and ADAS, and sometimes those are starting to merge together. But those have to vary at different rates, and across the vehicle platform is a common platform, and what will change depending on the level of the vehicle, the low end versus high end, they'll actually have different processors sometimes. In fact, one of the recent vendors in China showcased where they had one totally different vendor for ADAS than another between the low end and high end, right? So for ADAS, For infotainment, it's very dependent on the level of the vehicle tier.
It could also be a request to have everything in one brain.
Yeah, but the issue is that there's issues because what we're seeing is that OEMs want to keep those separate for upgrade reasons, for security reasons. We actually have people go to extreme lengths just to keep those totally separate, but the modularity is a big part, where you have this board and then you have the modules, and you can replace the modules over time or between modules, but the core vehicle stays the same. But back to your thing about ADAS and control and the autonomy and all that, right? That's more like the big brain, the high power GPU and control of
and
that.
People might want to upgrade that every couple, 3 years,
that's
but the rest of the car stays.
Yes, and what happens is, the vision, the perception, and the pathfinding and driving it, what that actually does is send commands to us as this brain. This brain actually does all the control of the steering. It says, emergency brake, it brakes. Speed up, the pedal. It is all controlled by this brain.
And how much updating happens here in terms of software updates and everything?
Good question. I get that question a lot, and also about data, because I'll show in a second that data in an SDV is the lifeblood of these. That uses data to monitor what's going on, data to understand the usage, data to understand the efficiency and all this, and monitoring security, and then there's a lot of data that gets sent to the cloud. We'll see that in the next demo. But definitely data. Now, code updates, that's a great question. We actually, with this kind of setup, once you go to an SDV, you have the ability to update it really rapidly, and that'll tie into the next demo. And we even show, if a car company has an idea on Friday, they could potentially the next Friday actually, for non-safety, they could deploy those type of features fairly quickly. And you'll see with the next demo, this is like the hardware, the architecture, the user experience. The next demo I'll show you, actually, let's walk over to this one. This one's about the whole software development side, because we need to continually monitor the vehicle, continually update the software, deploy it to the vehicle. So this is what we call NXP Cloud Studio. It's virtual development environment. So this allows you to go through that whole cycle. So let me show you what that consists of. There's 5 steps within this, and typically people call this the continuous integration, continuous deployment, or CI/CD. This is how we see SDVs going forward, where you're continually improving the vehicle, either safer, more secure, more features, more efficient, more range of the vehicle. So you go through a step of coding, building, you test it all within the cloud and virtual models, you deploy it to the vehicle, and then you monitor it real time. And based on the monitoring of the data, you can determine corner cases, you can determine areas for more efficiency, and then you go through this whole process. That's why it's an infinite loop. That goes on through the whole life cycle of the vehicle. Today, you buy a car, you get these static boxes, these dozens of boxes all over the car. A lot of those aren't updatable, right? They're stuck. Your car doesn't get better over time. This gets better over time. Let me just real quickly step through it. So I won't go to the details. This demo can go really deep into configuring your cloud. I can go through and start configuring what processor, do I want it running on Windows or Linux, my environment, and this is all running, by the way, at AWS Cloud, in a virtual private cloud, in an Amazon machine image. This can be portable, but we're focused on Amazon with this, AWS. For coding, so we have our S32 Design Studio, so we can run this in the cloud. So you go through your normal design, you can load a project, launch it, you're in your project, you can go through all your code, you can do all that. You can build it, go through that whole process.
So the software team can collaborate?
Yes, that's the beauty of this. So this chip can actually
around the world.
That's exactly right? It's about global collaboration. It's OEMs, it's tier ones, it's ecosystem partners, and it could even be us with drivers all working together collaboratively. That's a really key point.
Yeah.
That's what's driving this really, is that now, because of the scope of this, where everything is being integrated into a single chip, you can't just have like the old model of a little microcontroller where each developer is doing their own thing and it's in their own little world. They all have to be in the same world, but isolated within the environment. So that's exactly right. Now what we do is test. In the test world, we're using Synopsys in this, which is the Virtualizer Studio, Virtualizer Developers Kit. And what that allows you to do, when you load this, is actually run it like you're actually running it on silicon, right? But it's the same environment. And finally, you can deploy it. So this is like a campaign. We can go through, load it, and send it to specific cars. We can send a demo, send it down to the car. And then this is exciting. Once it's running, this is running in the vehicle. It was complete. Now this is the actual step 5 up here, right? It's the monitoring. So this is actual data that we captured the M-City test track in Detroit. And so we have this, and you can actually see, you could actually, from a real vehicle anywhere in the world, be able to monitor the vehicle, the speed, the battery current, the state of charge, battery stress, all of that, motor torque, location, all that is possible with an SDV.
All the fleet, the whole fleet?
The whole fleet.
Like if people agree, or they have to agree
that's
to buy
really
the
good
car?
Point. It's about the privacy. So that's a whole nother, that's what the OEMs have to deal with. Right?
I think, I'm not sure, but I think of Teslas, it's pretty much you can't have a Tesla if you don't agree to share all your data with them.
Yeah, probably pretty much. And I've been in Tesla headquarters, and you go in and you see this big map of all the vehicles. You can actually see some of this on the wall at Tesla.
But I mean, the purpose of this is to help make the EVs more efficient, better,
it's about
safer.
Yeah, it's like a big data loop where you bring data back in, you analyze it, you can determine if there's opportunities to improve the vehicle, and then you can monitor those improvements and continually improve. Now that could be machine learning models. You can improve a machine learning model that you deploy. It could be a new algorithm for battery management. It could be an algorithm for energy management. So you'll see OEMs, and I've seen some of this already with at least one of our customers, where incrementally they'll give you an over-the-air update and they'll give you 10 more miles of range. Right? They find there's all kinds of, it's like magic, but it's algorithms, very detailed algorithms that can make these more efficient over time.
Because the battery is supposed to get older and weaker, but actually the optimizations beat the battery, what's it called, loss of range.
Yeah, so exactly. So we've actually showed that. We had another demo we showed last year. It was the digital twin, the battery digital twin. And we could show, based on the driving behavior between an aggressive driver, a moderate driver, and an optimized driver. There's all kinds of algorithms we can do to improve it. We've even shown to actually improve range by about 29%. There are software you could download into the car that improves the range. But this is the key, right? SDVs, it's all about the data, and if you know the data, you can monitor it and find opportunities to improve it, and then you go back through that infinite loop again. It's all about optimization of the vehicle over time, and that's continual. CI/CD through the life of the vehicle. You can get behind the scenes things. You could have, like I showed over there, a personalization, which is a paid package or a subscription model. Who knows, right? There'll be a lot of business arrangements.
I'm so looking forward to sit on these self-driving cars and have the option of taking the optimized lower cost ride or aggressive one and have to pay a little bit extra because it's going to use more energy.
And there's subscription models. The cool thing about this is with the security built in and public infrastructure, we can take certificates that are actually time managed where they have an expiration date. So if I'm going on a trip and I want to have more performance, I could actually lease that feature for 2 days on a weekend, and that would, after the 2 days, it would automatically expire in the vehicle. I mean, there's all kinds of opportunities through software and the security to do amazing things in these vehicles, and this just shows you the behind the scenes of that infrastructure that allow totally new experiences to be developed.
So is this ready? The new chip and the cloud?
The chip. So we actually delivered this chip to customers in October. So it's been out there 6 months, and people are developing new vehicles around it, software-defined vehicles.
And the cars are coming soon?
Yes. I would say soon. There's still the whole
couple
process.
Years, something?
This production in second quarter of 26, so in that range.
Yeah.
Mid-26 into 27, you'll start to see a lot of that. As far as the software, we have all the software tools, and the beauty of having those models ahead of time is that even before silicon, we call it shift left. Industry calls it shift left, where you can move your software schedule a year ahead of time or so, and they were able to develop software before silicon.
Before the chips exist.
Right, but what we've done too, in this whole process now, is stretch right. So now you're leveraging the virtual model, this whole process I went through, you're stretching that whole thing. It's not done and gone, right? After you get silicon, you still leverage all this because it's efficient in the cloud. As you said, you could have hundreds of developers working at the same time collaboratively in this environment, and you have that infinite loop, so we stretch right. So
how much is open source?
Right. How much?
Yeah.
What do you mean?
How much of this stuff is open source?
Oh, sorry. I thought you were like cost.
Yeah.
How much? Open source. Good question. All of our, as far as like the tools we provide, a lot of it, like the Linux environment, all that is open source, of course. I mean, with the Synopsys and some of these tools, all these modeling tools, right? There's a business arrangement, so you could I guess people could integrate some open source modeling tools potentially, but yeah, there is a commercial arrangement for when you're using cloud time, when you're using a Synopsys model, there's
the car OS system.
So
how do you call it? The what runs on that brain?
Yeah,
I wonder what kind of.
We do offer. We have free
Is it
offerings
Linux?
like free. This has Linux, yeah. Well, not this one. Sorry, this is only the S32 N55 is only R cores, Cortex R cores. They're running at 1.2 gigahertz. They're running, and we show here, by the way, AutoSAR. We have EB AutoCore, which is also AutoSAR, free RTOS. There you go, and Zephyr, right?
Okay.
So you don't have to. We do support open source and free RTOSs on it. There's also support from people like Green Hills, Integrity, Wind River, all these types of VxWorks and such. There's a whole array of other OSs that can run on it.
All right.
Yeah. All right.
Thanks a lot.
Yeah, sure. Thank you for stopping by.
Thanks.
Appreciate it.